Hi folks, welcome to day 24. Today we're going to be talking about graphing y equals ax squared plus bx plus c. So today's video is a continuation video. We're going to be continuing on from day 22, which was our last day of video, so make sure that you've watched that before you start this video. So now that we know how to find the vertex, y-intercept, axis of symmetry, and the domain and range, now we're going to be able to graph our quadratics. And they have 4 key steps. So if we're trying to graph a quadratic of the form y equals ax squared plus bx plus c, your first step is to find and plot the vertex. So you learned how to find it and you already know how to plot a point. So you already know how to do that. And to draw on the axis of symmetry. Remember the vertex, the x-intercept of the vertex is just negative b over 2a. The y coordinate of the vertex, all you do is take that negative b over 2a and you're plugging it in for x in your function. And you're remembering to use PEMDAS when you're evaluating that, because otherwise you'll have some errors. We also know that the axis of symmetry is always at x equals negative b over 2a. So remember, that's always that vertical up and down line that the function is symmetric about. All right, so the function is always perfectly mirrored on both sides of the axis of symmetry. Your second step is to plot the y-intercept. And remember, your y-intercept is always this c value. That's why c is super important to know. The third one is the most difficult, and that's to go ahead and reflect the y-intercept over the axis of symmetry. So I'm going to go ahead and draw a rough example. So if we had our vertex here, looks like that's at 1, 3. So we have our vertex at 1, 3, and maybe we have our y-intercept at 0, 2. So when you're trying to reflect the y-intercept over the axis of symmetry, what that means is the distance between the horizontal distance, the distance left and right between your y-intercept, so between this point here and between your axis of symmetry, that space, so in our example, you can see that that's 1 unit of space. In order to have that as a reflection, you're going to be at the same exact height, but you're going to be moving. So if your y-intercept is 1 to the left, then you're going to, so 1 to the left from the axis of symmetry, you will move your new point 1 to the right. So it's going to be at the same height, but it's now 1 unit to the right of the axis of symmetry because the y-intercept is 1 unit to the left. If we had our y-intercept 2 units to the left, then we would move our new point 2 units to the right. And remember, that's to the left and to the right of this axis of symmetry. Don't worry, that's all that we're going to be talking about in this video, so I'll go over that in much more detail when we're going through explicit examples. Our fourth step is our easiest step, and that's to connect the dots. So if this was our example, go ahead and get rid of some of this extra stuff. If this was our example, then we would have to plot the vertex, which is in purple, the y-intercept, and then the reflection of the y-intercept. Then all we do is connect it with this U shape. All right? So that reflection just means that it's the same distance on either side of the axis of symmetry. All right? So it's always at the same height, and it's equal distance from the axis of symmetry. Let's go ahead and try out an example. So this is what I was talking about as a continuation of day 22. So we have the function y equals 2x squared plus 8x minus 1. So in the day 22 video, we found the vertex of this function, and we found it to be -2, -9. If you want, you can go ahead and pause the video now if you want to try out finding that vertex, because now you know what the answer should be, so now you can check your answer, check your work. We also know that the y-intercept is at 0, -1, and we know the axis of symmetry, which I'll typically abbreviate as AOS, only because axis of symmetry takes a long time to write. But that axis of symmetry is at x equals -2. So remember, that was all from the day 22 video. Now, using what I've learned in this video, I'm going to plot the vertex and the axis of symmetry, plot the y-intercept, and then reflect it and connect the dots. So I'm going to start by drawing out my my chart. All right, and when you're drawing these, it doesn't have to be super precise. You can see my lines aren't super straight either. That's why if you see I'm like drawing a line that is kind of squiggly, and then if I hold it down a little longer, it adjusts to that line. So if you're trying and struggling to make your X and Y axes in Notability, you can use that trick. All right, so I know that I have points at -2, -9. So you can see, as of right now, I do not have my line going far enough down. So I'm going to go ahead and redraw them so that way they are going far enough down. All right, there we go. That looks much better. So I have my points at -2, -9, 0, -1, and then I know I'm going to have some other point at that -1 height as well. So I'm going to go ahead, put in little tick marks here so I know what counts for what. I'm going to make each line on the X count for 1 unit, and I'll make each line on the Y count for 1 unit. All right, so now we're going to go ahead and plot our 3 points. The first point we're going to plot is our vertex. Our vertex is at -2, 9, so I'm going to go to the left 2 because that's my X, and then I'm going to go down 9 because that's my Y. So I make my first point at -2, and down 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my first point down there at -2, -9, and that is my vertex. Since it will ask me to label it, I'm going to get in the practice of doing that now. As soon as you plot your vertex, your next step should always be drawing in that axis of symmetry. I strongly recommend drawing this in either in a different color or in a dotted line, so that way you can see it really easily up and down your page. All right, now I'm going to go ahead and plot my y-intercept at 0, -1. So on the y-axis, I go ahead and go down -1. So then I have my my y-intercept at 0, -1. My final point that I need is to go ahead and reflect this point over that axis of symmetry. So since I have 2 spaces to the right of my axis of symmetry, since it's symmetry or symmetric, meaning it's the same on both sides, the only way for that to be true is if I had 2 units on this side as well. But remember, I have to have it at the same height. So since this is the height of my axis of symmetry, or sorry, since that's the height of my y-intercept, that's also going to be the height of my new point. All right. So I'm going to have my my third point right there. And that is at -4, -1. So it's really important here. This height of -1 is the exact same in both the y-intercept and the point that I plotted, right? My new point that I picked. Because I picked that point, right? Because I'm not going off of a t-chart. But since I'm not going off of a t-chart, the only way that I know that it's guaranteed to be that this point is on my function is if I use the fact that this is a symmetric function, it's the same on both sides, and I reflect it. So if you ever are trying to reflect a point and you end up like somewhere down here, right? Or if you ended up like way up there, you know that you are not in the right spot if your function, when you connect all the dots, if it doesn't look like a U. Right, so I'm going to go ahead and connect my dots, and you see I have a U shape. It's a little pointed, but it's still a U. So that's all you have to do in order to graph. So for today's assignment, you're going to take those 4 problems that you already found, the vertex, the y-intercept, the axis of symmetry, and the domain and range from day 22, and you're going to be plotting them just like I did here. So at this point in the video, if you feel confident in your ability to graph based off of this example, feel free to go ahead, stop the video, go work on the assignment. However, if you feel like you need just a bit more help, I'm going to go through an entire second example from start to finish. So you're welcome to keep watching. All right. So for this example, I'm going to be working with a -a. So I have -3x squared. And I also have a -b. So -6x and +5. So what we're going to have to do is we're going to have to find the vertex and the axis of symmetry. We'll also need, in order to graph, we'll need the y-intercept, so it's important to identify at the beginning. And since I told you that I would do a full problem, I'll also show you the domain and range as well as graphing it. But I think the hardest part, and the part that I will do first, is the vertex. So when we're trying to find the vertex, we always start with our formula, -b/2a. So if you haven't already, make sure you identify your a, your b, and your c. So we have a is equal to -3, b is -6, and c is 5. If you'd like, now would be a great time to stop the video, try and find the vertex, axis of symmetry, y-intercept, domain and range on your own, as well as graph it, and then come back to this video to see how I complete it. The reason why I suggest that is because a lot of you have been reaching out because you're struggling, and so it's really important to practice what you're trying out as we go through. This way you can see if you're getting the right answers along the way, since I can't give you immediate in-person feedback since we're teaching during a quarantine. All right, so we have -b/2a. I'm going to start by putting my negative sign and my 2, so that way I don't forget them. Since b is equal to -6, I'm going to go ahead and put that in parentheses up at top. But my 6 doesn't look very good, so I'm going to rewrite it. All right, so now we have -b, so because we have negative, and then b was -6, and we divided by 2 times a, and a was -3. All right, so we have -6 divided by 2 times -3. -6 is just like -1 times -6, and negatives times negatives just gives us positives. So on the top, we're just left with +6. On the bottom, we have 2 times -3, so that gets us a -6, which gets us a -1 as the x value of our vertex. Since we also have to find that axis of symmetry, I'm going to note it right here. In fact, I'm going to do it in a different color since I can. Whoop. So the axis of symmetry, remember that axis of symmetry is always at the x value of your vertex. The x value of your vertex is negative b over 2a, so the axis of symmetry is at x equals negative b over 2a. And in this case, negative b divided by 2a was equal to negative 1. So our axis of symmetry is at x equals negative 1. All right. Now that we have the x value of a vertex, we have to find the y value of a vertex. So I know that y equals 3x squared minus 6x plus 5. But when we're thinking about it, our vertex that we're thinking about is at x equals negative 1, so I have to go in and replace all of these x's with my negative 1. Alright, now I can go ahead and continue. So we have y equals negative 3 times negative 1 squared minus 6 times negative 1 plus 5. It's really important here at this negative 6 times negative 1. A lot of you have been writing this without the parentheses, and if you write it without parentheses, it looks like negative 6 minus 1. It's really important, if you're not going to put the parentheses in there, you have to put some multiplication sign, whether it's a dot or a little x, something to denote that there's multiplication going on there. I'm also going to remind myself that I have to use PEMDAS in order to try this out. So we get y equals negative 3. The first thing I'm going to do is get rid of my parentheses and my exponent right here by evaluating that exponent. So I will make a note here that if you are putting this into your calculator, if you put this in as negative 1 squared, to your calculator, because it's not very smart, it reads it as negative 1 squared, which means that you're not actually getting rid of the negative sign, right? We have negative 1 squared, which is the same thing as negative 1 times negative 1, which is positive 1. Whereas up here, if you just put in negative 1 squared in your calculator, you have negative times the quantity 1 squared. 1 squared is just 1, but you have the negative on the outside, so that one you get negative 1. Some of you on your t-charts aren't getting the same values. Those of you that are still using t-charts, you're not getting the same values for your x's across the different, like for your different x's that are symmetric. And the reason why you're not getting the same x is because you, when you're evaluating this into your calculator, you're missing this step. So make sure you're including those parentheses. All right. I just needed to make that note real quick. So we have to go ahead and get rid of those exponents first. So I have that squared. So I'm going to have negative 3 times negative 1 squared. Negative 1 squared is just 1. So then I have negative 3 times 1 minus 6 times 1 plus 5. Now I can go ahead and do my multiplication. So I have negative 3 times 1 here, which gets me negative 3. I have negative 6 times negative 1. If you saw, I almost forgot that negative sign. So it's really important when you're doing this algebra, don't drop your negatives. But for the next part, we have negative 6 times negative 1. So I get positive 6 and then plus 5. Negative 3 plus 6 gets me plus 3. And 3 plus 5 gets me 8. So my vertex, since the x value of my vertex is at negative 1 and the y value is at 8, my vertex is at negative 1, 8. All right, so we found the vertex. That was the hard part. Check. We also, in the process, found the axis of symmetry. Our y-intercept is just c. So our y-intercept, Since we have y equals negative 3x squared minus 6x plus 5, c is 5, so our y-intercept is at 0, 5. So we did the y-intercept. Excellent. All right, domain for every single quadratic is all real numbers, or that double-lined R. For our range, we have to look at the a value. So our a is negative 3. So since a is less than 0, it's a negative number, we know that y is going to be less than or equal to the y value of our vertex. In this case, the y value of our vertex is 8, so we say for the range, y is less than or equal to 8. All right. We did the domain and range. Last and final step is to graph. Now, graphing, we're just following the exact same steps we did with our first example. So we're going to go ahead and graph our vertex, graph our y-intercept, and then reflect that y-intercept over the axis of symmetry. All right. So I know that my point is at... my vertex is at negative 1, 8. I'm going to leave myself a lot of space up top. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Since I know that the function is at y is less than or equal to 8, part of why that's really helpful to know is that now I can really easily graph this because I know exactly how much of my paper to section out. I still section out like more than enough, but still. And on the x's, we go ahead and section out the x's with the points of 1 as well. All right, so now we're going to go ahead and graph it. So we have our vertex at negative 1, 8, so we're going to go ahead and graph that first. So I'm going to go to the left 1, and then I'm going to go up 8. So my vertex is right up there at negative 1, 8. Since I'm already on the vertex, it's a really great time to go ahead and draw in that axis of symmetry. And we know that that's at x equals negative 1, because that's the x value of the vertex. My y-intercept up here is at 5, so I'm going to go ahead and go up to 5. All right, so you can see that now we have our y-intercept plotted. Our final step is to reflect that over the axis of symmetry. So you can see we have 1 width away on the right side, right? One unit of width away on the right side. So on the left, we're going to need 1 unit of width away as well. But remember, staying at that exact same height. So that means our reflected point, which I'll call our R point, is at negative 2, 5. Now that we have all 3 of those points in there, we go ahead and connect them with a U. And that's our final step. So again, all you have to do for today's assignment is, yesterday we did all of this hard stuff that I walked you through at the beginning of this, right? So hopefully you feel better now watching this. And then all you're doing with yesterday or with day 22's assignment is taking those equations, plotting your vertex, plot the y-intercept, reflect that y-intercept over that axis of symmetry, connect to those 3 dots with a U, and you're good to go. Make sure you're emailing me if you have any questions, all right? Other than that, that's all I got for you today. Good luck on your quiz tomorrow.